Okay, so earlier we talked about epithelial tissues and their characteristics. Keep in mind again that epithelial tissues are tissues that touch one another and they have a surface that is exposed to the environment and another that is connected to the connective tissue below. Now, having talked about that, let's talk about the connective tissue. Connective tissues are found everywhere in the body, and they are the most abundant and widely distributed of tissues. I know we said that epithelial tissues are on every surface, but underneath all epithelial tissues is connective tissue. And so connective tissue functions to bind bodies, tissues together. It supports the body and provides protection. Examples of that when we talk about support of the body, well, bone is a connective tissue. And bone provides protection for, say, the brain, which is surrounded by the skull. We also have protection in the form of padding, which is provided by another connective tissue, which is fat or adipose tissue. Now, let's take a look at some of the other characteristics of connective tissues. Um, Epithelial tissues, as we mentioned before, don't have or don't have a blood supply going directly to them. In fact, they get their blood supply and their nutrients from the connective tissues below. Connective tissues have a wide variation in blood supply, and some types are well vascularized. That is, they've got lots of blood vessels. There are some that have poor blood supply. There are some that are avascular, which is to say they don't have a blood supply. And examples of that are the cartilages. Now, one characteristic that all connective tissues have in common is that there is an extracellular matrix. Now, epithelial tissues, those cells actually abutted up against one another. In connective tissues, what we have is cells that are actually fairly widely spaced with a material that has been produced, a non-living material, that is separates them, lies in between them. Now, that matrix consists of a variety of things. Actually, it has two main components. There is the ground substance, which is mostly water. It has some adhesion proteins, some sugar molecules, and it can be anywhere from a liquid matrix to gelatinous matrix to actually quite solid. Um, we have fibers that are produced by the cells. And there are three types of fibers. There's collagen fibers, which are very strong in tensile strength. They have been referred to as white fibers. They don't have very much give to them at all. We have elastic fibers, which are stretchy, and they are sometimes referred to as yellow fibers. And then there's reticular fibers, which just go in all directions. They're very thin fibers that act kind of like a scaffolding to hold organs and other structures together. Let's talk then about individual connective tissues. And the first one we should talk about is bone. That's the one we're most familiar with. This is also referred to as osseous tissue, and it is composed of bone cells. We have three basic types of bone cells. We have osteoblasts, osteoclasts, and osteocytes. It's the osteocytes that live in these things called lacunae, which are little cavities inside of the bone. There's a hard matrix of calcium salts, which gives bone its stiffness and rigidity, and there's a lot of collagen fibers running through there that adds to the flexibility and strength. The collagen kind of acts like steel reinforcement if you're looking at steel reinforced concrete. This is used to protect and support the body. So we have several organs that are protected by bone. We have the lungs and the heart. We have the brain and the spinal cord. And, of course, with bone, we have a solid thing that we can attach muscle to so that we can facilitate movement. This is a view of one type of bone. So we have something called spongy bone, and we have compact bone. This is a cross section showing some compact bone. And there is a structure that is the basic unit of compact bone called the osteon. And that is this round area here. Now, in the middle of an osteon, in the middle of every osteon, there is this central canal. And that canal contains a blood vessel, nerve supply, other things that travel through the bone. Surrounding that canal are rings called lamellae. And if you notice these dark spots lying within the rings, those are the lacunae where the osteocytes live. Now, we can go into a great deal more depth on bone, and we will when we get into the skeletal system. For now, I just want you to get the basic concepts, understand the general characteristics of the tissues that we mention here. One thing to be aware of when we talk about the connective tissues, the hard connective tissues, and even the rubbery ones, they all have lacunae. That is, bones and cartilages contain lacunae, and that's where the cells live. When we have a cell that is a maintenance cell, it's called a site. A cell that builds something is a blast, and the cell that breaks down substance is a clast. So you'll hear those terms used in the future as we go through other connective tissues. Now, our next connective tissue, which is very widely spread, is hyaline cartilage. It is the most common of the cartilages, and it is, it's got a lot of collagen fibers. It's rubbery in nature. The entire fetal skeleton is made of hyaline cartilage, which eventually gets converted to bone. It is still mostly hyaline cartilage when we are born, which is very important because it allows flexibility and allows the baby to pass through the birth canal. If it were bone, it would be very difficult for that to occur, if not impossible. It also makes up the Adam's apple, or the throat, your larynx, and it's located on the ends of long bone. Now, hyaline cartilage does not have any blood supply at all. That makes it perfect on the ends of long bone because we can have this material rub against another bit of hyaline cartilage, and it offers a low friction environment without running the risk of bleeding into the joint. If you look at these images, this is hyaline cartilage, and it has sort of a glassy appearance. You really can't make out the fibers very well. They tend to be pink, purple in color, and the cells, the chondrocytes, again, in lacunae, tend to be paired. So we have, little groups of cells. There's still matrix in between them, but like these two are close together. Another place, by the way, that we have hyaline cartilage is at the ends of our ribs, because we need a little flexibility in those ribs to allow us to breathe. And so this is the part that has enough give that we can breathe well. Other cartilages include elastic cartilage, and naturally it provides elasticity. It's loaded with elastic fibers, so it has some stretch and give and will spring back into the appropriate location. It is, one location at least, is that it supports the external ear, and so the ear can be pulled a little bit and it will flip back into place. Fibrocartilage is very highly compressible. It's kind of almost like a rubber ball. It forms the disc in between the vertebrae. So it's got a little give, it's got a little bounce to it, and allows us to bend and twist a little bit between each joint. Fibrocartilage, you can see it has lots of collagen fibers, and those collagen fibers are running generally in one direction, and that gives it quite a bit of strength. And you can see again lacunae, little pits here, or lakes that contain the cells. Now these little dark dots are the shriveled up cells that were in that tissue. There are other connective tissues. We've just mentioned 3 of the cartilages. Now we'll look at tissues that are often referred to as connective tissue proper, as these are tissues that actually bind between one structure or another. There are dense connective tissues, there are loose connective tissues. We have dense regular, dense irregular, and so on. So the dense fibrous connective tissue, and the main element here that we're talking about is collagen fiber. Again, remember that's very strong, doesn't have much stretch at all, and it is good under tension in one direction. The cells that make that are fibroblasts. Remember we said that when we build something, the cell involved is a blast. Now, locations, well, tendons, which attach muscle to bone, ligaments, which attach bone to bone, the lower layer of your skin, the part that we think of as leather, is made of this dense, irregular connective tissue. Tendons and ligaments are made of a dense, regular connective tissue. This is, again, a very strong tissue. This is a view of a tendon, and it's been cut, so there's a little bit of waviness here. This would normally be straight, but since tendons are under tension, once it's cut, it did kind of collapse a little bit. But most of this that we're seeing are collagen fibers, and we see occasionally the nuclei of some of the fibroblasts that actually build this material. One of the prettiest of the connective tissues is areolar tissue, and this is the most widely distributed connective tissue in the body. It is very soft, it is very pliable, it's got a cobweb-like appearance. It is a packing tissue, and whereas dense regular connective tissue is collagen, elastic cartilage, a lot of elastic fiber, this contains all 3 fiber types, and it's the only tissue that does. Because it is very loosely packed, it can soak up a lot of fluid, so when you get edema, what you're doing is you are absorbing fluid into this connective tissue. It is, as I said, a very pretty tissue. I was an art major, and was working on a master's in fine arts, actually. So to me, looking at this looks a lot like a painting by one of my favorite artists, which is Jackson Pollock. But we see streaks of thick pink collagen fibers. We see very thin, kind of wavy elastic fibers, and then some of these dark linear fibers are also reticular. It's very distinctive in appearance. It's easy to recognize, so you should be able to identify areolar connective tissue without any problems. Now, at this point, I'm going to stop and we'll pick up on the remaining connective tissues, beginning with the other types of loose connective tissue, adipose tissue, things like that, in a subsequent presentation. So, again, I hope this has been helpful to you, and thank you again.